Hey, algebra students. Today we are doing the application part of our solving quadratic. So your one learning target number 9, solve geometric problems by solving quadratics. And last time we talked, we kind of went over 4 of the major ways of solving quadratics, by factoring, by taking the square root, by completing the square, and using the quadratic formula. So all 4 of those are certainly possibilities, but here you can pick whichever one of those 4 you would like. All right, so a few things that you'll want to pick up just real quickly before we get into our application examples. Volume, I guess, would be one thing. Volume is going to be, or at least of a box, is going to be length times width times height. So hopefully you know that one already. Pythagorean theorem, if you've got a right triangle, then you've got 2 legs, we'll call them A and B, and then the hypotenuse C. A squared plus B squared is always going to equal C squared. And so, by themselves, at least this one, you take a look at it, and the only way we're going to get some quadratics in here to solve is if we wind up having like an x plus 2 and an x or something like that. But we multiply those together and we'll get an x squared. Here you can see we've got some possibilities for things that are squared. And then the height of an object. This is a real common one that you hopefully picked up in maybe algebra 2, pre-calculus. You use this a lot. The height of an object is negative 16t squared plus vt plus s. So a lot of variables floating around here. Let's figure out what those are. The h stands for the height of an object, and the independent variable that goes with it is t, so that would be time, usually measured in seconds. And so h is the height of some object that's been tossed into the air after a certain number of seconds, and that leaves us with v and s. So v stands for the initial velocity, and s stands for the starting height. So if I had kicked something from the ground, the starting height would be 0. So these are some basics that will help us write our equations here. All right, so situation number 1. You got a piece of machinery that produces rectangle sheets of metal. Again, I really don't care so much about the body until I know exactly what I'm trying to find. So I skip down to the last sentence here, and if specifications call for the volume of the box to be this, so volume is this, find the dimensions of the original piece of metal. All right, so find the dimensions. That's what I'm aiming for here. Volume, I know it's a 3D shape. So, all right, now I go back and I start reading. It's a rectangle sheet, so anytime I've got a geometry type problem, I'm going to be drawing my diagram. And it says the length is 3 times the width. Well, all right, so that means I've got the width, we'll call that W, and the length is 3 times the width. So 3 times W. Now it says equal-sized squares measuring 5 inches can be cut from the corners. So each of the corners is going to be cut out like so. And each of these has a dimension. It's 5 by 5. All right. Well, I'm going to fold up after I cut out these squares, and that'll give me my box. So how do I find the volume of this box? Well, we do know that volume is length times width times height. And, well, volume The length, well, the length would be 3w, except I'm cutting out 5 here and another 5 over here. So it's going to be 3w minus 10. The width will be w, but again, I'm cutting out 5 and then 10, so w minus 10. And the height, well, if I'm cutting out 5, that means that when I'm folding up, this part right here would be the height, and that's also 5. So I'm going to be multiplying through by 5. Length times width times height. Now I also know that my volume has got to be 1,435. So cross this out, 1,435. All right, well, I've got the start. Now I need to start solving for W. That'll give me my width at least, and I can use that to find my other dimensions. So here we go. I guess to start off with, I'm going to FOIL this out right here. And that's going to leave me with 3w squared minus 40w. So minus 30w minus 10w, and then plus 100. And, well, let's see. I still have this 5 hanging out here. So 1, 4, 3, 5. I think rather than going ahead and like multiplying that in, I think I'm just going to go ahead and divide both sides by 5. And that's going to leave me with 287. So 1435 divided by 5, 287, equals just what I've got left here, 3w squared minus 40w plus 100. Okay, well, I can clearly see that I've got a quadratic on my hands. If I'm going to solve this by either doing the quadratic formula or by factoring, I'm really going to need to make it equal to 0. So I guess the next step here is I'm going to subtract 287 from both sides, and that'll leave me with 0. Then I got 3w squared minus 40w, and then 100 minus the 287 is going to leave me with negative 187. So I guess I got the choice. Could I solve this by factoring? Do I want to just go ahead and try using the quadratic formula? Between 340 and 187, I look at that and I think, you know what? I think the quadratic formula might just be a faster way than me actually coming up with factors that will give me 40 there. So I'm going to go ahead and use the quadratic formula. Instead of x, I got w, but I've got b squared. So negative 40, so 40, plus or minus the square root of negative 40 squared minus 4 times a, which is 3, times c, which is negative 187. And we're going to take this all and divide it by 2 times a, which is 3. All right, next I'm going to find my discriminant. So negative 40 squared minus 4 times 3 times negative 187. That boils down to 3,844. Pretty big number, not a real common number. But if I take the square root of that, wow. Square root is 62. So I got 40 plus or minus 62 divided by 6, which tells me, well, you know what? If I had wanted to, I could have figured out factors. Going ahead and 40 plus 62 divided by 6, that gets me W equals 17, or negative 3 2/3, negative 3.6 repeating. And obviously the width can't be negative, so this is an extraneous solution. That doesn't help at all. So now that I've got the width, I can go ahead and find my other dimensions. The length, remember the length was 3 times the width, so that's going to be 51. And of course my height was what was given originally, and that was 5. All right, there we go. There's solving a problem with volume. Let's go ahead and see what else we've got. All right, you got a piece of property, and it's in the shape of a right triangle. because all properties are in the shape of right triangles. Not. All right. So the longer leg is 20 meters longer than twice the length of the short leg. All right, so that means what I don't know is the length of the short leg. The longer leg, 20 longer than twice. So I got 2L, and then I'm adding 20 to that. Okay, so that's neat. The hypotenuse is 10 meters longer than the length of the longer leg. So 10 meters longer, well, that would be 2L plus 30. Just add 10 on. Okay, so I've got my, well, dimensions. But knowing that this is a right triangle, I can go ahead and use the Pythagorean theorem. So I'm going to start setting this up. L squared plus 20 plus 2L squared equals the hypotenuse 2L plus 30 squared. All right, boy, we got a lot of kind of special binomials here, and that's going to be nice. So if we remember the shortcut, then we can just kind of immediately set this up. I'm going to go ahead and now say that this is 4L squared plus 80L, and then plus 400. So they're on the left. That's what we get when we expand 20 plus 2L. Let's see, and then over here for this one, if we expand that one out, we're going to get 4L squared plus 120L plus 900. All right, well, we have a pretty nasty long equation here. Let's start boiling this down. L squared plus 4L squared, that would be 5L squared. And so here, plus 80L plus 400 equals 4L squared plus 120L plus 900. Okay, again, it looks like I've got a quadratic on my hand, so that means I'm going to want to make it equal to 0. And so I'm going to start subtracting and kind of throwing all this stuff over here. So 5L squared minus 4L squared, just be 1L squared. That's convenient. 80 minus 120 is going to be negative 40L. And then 400 minus 900 would be negative 500. All right, well, is this one factorable? And actually, I think it is. I kind of look at it and I can see